So we've got this graph of a function g of x. We're supposed to find the point C at which the function has a jump discontinuity but is right continuous. So for something to be right continuous, you need to have a solid dot. It needs to actually exist at that point that you're analyzing, and then it needs to be continuous, meaning you could like take your finger and trace it without having to lift your finger. So if we look at x equals 1, it's definitely a jump discontinuity because we jump from here up to here all of a sudden, then we keep going on with our function. Okay, these are not math definitions. There's obviously a more concrete definition for jump discontinuities in our text, but so it has a jump discontinuity at x equals 1, but it is not right continuous because of that open circle. If we look over here, we got another jump discontinuity because we jumped down from here to here. And then this one is right continuous because there's a solid dot here. And we keep going. There's another point of discontinuity at x equals 3, but we call that a removable discontinuity because there's one point that's at x equals 3. It's discontinuous. It has an actual value at x equals 3, but it's not part of, the limit from the left and limit from the right are the same. That's the more math way of putting it. So the jump discontinuity, but being right continuous, meaning a little bit greater than x equals 5 and having a solid dot, that's this one here. So at c equals 5. And then they said, hey, at g of c, in other words, we just found out what c is, at g of 5, what value should be assigned to make g left continuous at x equals c? So it's kind of wordy there, but we found out that c equals 5. So at c equals 5, what y value would have to be there so that we wouldn't have a left discontinuity? So we just basically have to fill in that circle. And at y equals 4, then we no longer have discontinuity. Okay, so the y value needs to be a 4 to fill in that hole. Again, this all comes from the definition of continuity. The limit has to exist, and the actual value, if you plug in the value, that has to exist. So this is like the closed circle part of the definition of continuity. Okay, you have to have a closed circle, and this is the part where you think about approaching x equals 5 from the left and from the right. But okay, I hope that helps with this question.